Hello. Hello. Hooke. Okay. Hello. Welcome back, everybody. Okay, thank you for doing that. Oh, the all smells thing is intense. That's talk about Bitmojis. Okay, that's awesome. Welcome everybody. So all right, we have about 25 minutes. I'm trying to get my board back hooked up. Obviously, I would like to start talking to you about this material. Couple things, and I want to hear what happened in the room. More people. I want to hear what happened in the rooms. I want my board to come back. I don't know where it is. But hello. A couple logistical things you may have, again, if you did game turn 1, then hopefully you've gotten it back. And if not, let me know in the private chat. If you did homework 1A, if you did it at all, if you did it on time, you got full 20 points. I didn't even put comments on it. I just wanted the exchange. I wanted you to start off on that foot. So if you did it, you got the 20 points back. Hopefully you saw that. If not, let me know in the private chat. I mean, I read them. I did not put comments on them. I just wanted to see that we were on the same page. If you turned in, just to be clear, if you turned in already homework 1B, which is worth 35 points, then you've already gotten 22 out of the 35 points just for turning it in like early. It doesn't mean, again, everybody else can still get all the points, but it means you already know you have 22 points in the bank. And then we're going to, and you could still, of course, resubmit it or wait for me to give you more points as I see all your answers and all that kind of stuff. But that happened automatically just if you just already turned it in at all, just to acknowledge that. Not that I want to obsess about points all the time, but I just no problem. No worries. Private chat person, no worries. Again, just trying to be clear and all of that. Of course, I want to get onto the physics. There was one other thing. Oh, but hopefully you also noticed maybe while you were in the breakout rooms, a couple other logistical things happened. Now that we've acknowledged like who still needs time to start homework 1B, and we've acknowledged like who already started it. Now that it's already there, you'll notice I extended the deadline, the official deadline for homework 1B. So till a week from this Wednesday. We're going to spend that long on it. And I knew that from the start. There's a lot going on in that homework, a lot of chance to sort of reconnect old ideas to new ideas. So everybody can still have till next Wednesday to get all the points on it, wherever you are at it now. And there's no other real homework that's being assigned in the meantime. So please do take it seriously. Again, I will warn you right now, again, the very last question on the whole thing is definitely hard. You will want to do like a web search or see what you can find out about the very last question. And of course, we're all going to go over it together in a big way. We're going to spend a long time on the last question, but I want you to see what you can find out on the web or in books and talk to other people. Just remember, you can write down anything that you learn from anywhere, but don't write it down unless you think you understand it. And if you got a fragment from somewhere like Khan Academy or something on the web, you saw something that seems to relate to question 9 and you think it's relevant, you think it might even be right, but you honestly in your heart don't get what they're talking about, just write that. Like write the equation that you got, but say, I don't understand this, but I found this online. And then, to be even better to yourself, what you might do is say, I don't understand this because I don't understand this term in the equation that I found online. Then that might prompt you to look up that term, et cetera, et cetera. Like you might end up being able to help yourself. But I'm just saying, just be honest about what you do and don't understand. And the more you can self-diagnose, the more you will self-cure, so to speak. Okay, that's all about that. The other thing that you would have noticed logistically while you were in the breakout rooms, hopefully everybody's noticing or knows that I do post all these recordings and post all these PDFs after every class. Today's class will be sort of 2 recordings because of all the dead space in the middle. But hopefully you noticed also that there's a bunch, and stop me in the chat if any of this you did not, if you're looking right now in Google Classroom, you don't see what I'm about to say or what I'm talking about, or you didn't get those points that I said you did, let me know. But I think you also notice in Google Classroom that a huge number of the other game portals have all been opened up. And if you look at them, you notice they're worth all different kind of points, not just 5 points. And all of them are due like May 17th or whenever the last Wednesday of the semester is, which means you can do them at any time and you can do them repeatedly, but just anyone that ever applies to you. Like if you're the kind of person who's been showing video, a portal has opened up where you can just type in like, I showed video today, or screenshot it, I showed it, and you'll get the points for that day. And then if you do it again the next time, you'll get the points again, etc. But all of those like sort of other optional portals are open now. If you've never had me before and this is not making sense to you, I totally get that. Please reach out to me and I'll explain it better or more, more. Okay, but that's a lot of portal. None of them is meant to be intimidating. They're all just options for points or to encourage different ways of participating when they apply to you. Okay, that's that. Now my board is still not home. I'm trying to get my board going here. Pardon me for a second. But now what I would like to talk about physics. Okay. And something in the chat, but I think I acknowledged the chatter. Oh, yeah. Oh, okay. No. Thank you for your honesty, Olsmael or Ms. Olsmael. Yeah. The 20, if you got a 22 on homework 1B, that's totally up like a provisional benchmark. That's like it just means you've gotten the 22 out of 35 already, just for the fact that you're all getting more points to come. That is not a final, right? I think you get it now, Olsmael, I think, but everybody, that's not a final score. It's just that much more than 0 for right now. Okay. If it's not clear, tell me in the chat. Okay, my board is back. Now, I want to start talking about that. I want to start helping you or going over it a bit and helping you. Hopefully, you helped each other. Oh, here's a little. Raise your electronic hand or somehow electronically acknowledge if in the room that you were in, if there was any kind of mixture at all between either, and you don't have to name names, you don't have to identify who you are in this mixture, but if there was any mixture at all of either people who started the homework, people who didn't, or people who knew about the 5-step method and people who didn't, just electronically acknowledge if any kind of mix like that was in your room. Cool, thank you, cool. Just keep them up or keep doing it. I just want to, cool, thank you. Awesome. Okay, I'm just looking. Okay. Good. Now put your hands down, please. And I'm going to ask the reverse now to put people raise, because some people didn't raise their hands. So I just want to make sure. Electronically acknowledge, raise an electronic hand somehow if the opposite is true. If your whole room, like there was no mix, it was all people who had already done homework, or it was all people who had not done homework, or it was all people who did not know the 5-step method. Just raise your hand if your whole room was, oh, is that right? Is that Nicola? Oh, there were such rooms. Oh my God. So I want to pause for, wait, there were a lot. Oh, see, and I thought people weren't voting. Bad on me. So 6 of you, and keep them up for a minute if you don't mind. 6 of you are saying, or 6 of you a moment ago, keep them up for a second. So 6 of you are saying that your room was straight up homogeneous. That is important for me to know. So maybe you may not want to. Can I ask you, can one of you, and you were 2 different rooms. That's 2 different rooms, I think, right? Yeah. So wait, I just want to know, this is no shame, no blame, no judgment. Could one of you just like from each of the rooms, just tell me what was even if you're telling me none of us in the room had started the homework, it's fine. But I just want to know, like, I mean, I just want to know what was going on. Oh, okay. Oh, okay. Oh, that's a relief. Well, that's less embarrassing, isn't it? Okay, wait. So and were you guys, thank you, Sophia, and thank you, Brianna. See if Sophia and Brianna, were you in the same room, or are you speaking for one room, or are you both speaking for a different room? The same, okay. You all, huh? Oh, and then you, okay. Okay. Interesting. Okay, okay. All right. Well, at least that's good news. Okay, so maybe those rooms were, maybe you were bored in those rooms. I won't ask that question, but okay, so at least we're all okay. Thank you. Totally appreciate it. Totally appreciate it. Okay. I'm going to start going over it now. I know we only have 15 minutes. I'd like to get rolling on it. Again, it gets harder and harder and gets more, but, or maybe well, yeah, I'm going to start rolling on it. But one thing, and I'm going to keep coming back to this theme. I want to remind you of something I said very quickly at the end of last class about homework 1A, which we did very quickly, and it's very abstract and everything. In fact, okay, I'm going to ask everybody to write this down. Please write this in your notes before I get rolling on the spring, before I get lost in the math, and things will be very mathematical from here on in. Let me just remind you, and please write this down. A particle is an entity that cannot occupy 2 points of space at one point in time. Okay, that's a particle cannot occupy 2 points in space at one point in time. And by the way, that very, there's maybe a slightly more technical definition of a particle. Maybe even more technically, it's a particle cannot occupy 2 states at one time. Maybe state can be more broadly defined. Maybe it includes such things as energy or electron orbital or something like that. But for our purposes, a particle is something that cannot occupy 2 points in space at one point in time. And so that's A. And B, a particle cannot co-occupy 1 point in space at one point in time with another particle. Okay, I'll just say this whole thing one more time. This was like the takeaway from homework 1A or from last week or whatever. A particle is an entity that cannot be in 2 places at once and cannot be at one place at once with another particle. That's what a particle is. Okay, but let me just remind you, that's what a particle is. All of physics is about the study of observable, measurable, reproducible, analyzable, predictable motion through space and time. Anything that occupies space and time in a measurable, predictable, analyzable way is part of physics. Particles are things that occupy space and time in the very specific, constrained manner that I just described. Particles are entities that occupy space and time in a manner that is constrained by those 2 specifications we just made. But there are plenty of entities in the world that occupy space and time in a measurable, analyzable, predictable way, and yet are not constrained by A and B, the 2 things I just said. All those such entities are the ones we are ultimately here to study in Physics 204. We are here to study water waves, sound waves, electrical currents, electrical fields, magnetic fields, gravitational fields, and ultimately electromagnetic radiation. And did I say electrical currents? I think I did. We are here to study things that are actually things that are real, that are measurable, observable, predictable, analyzable, and that move through time and space. But we're here ultimately to study things that can be in 2 points in space at the same time, such as a sound, or can be at the same place at the same time as another such thing, such as a sound. Something I often do right now. I'm worried about the time, so I want to get to the sheet. But just notice, if anybody were to shout out right now, if anybody were to talk while I'm talking, if I asked them to, those of you listening would hear their sound and would hear my sound, right? It would be like hearing two notes at the same time, which often we call a chord or part of music, right? And that would mean that both sounds were literally landing on your eardrum, occupying a point on your eardrum at the same time in the same space, and not by accident, and not in some fuzzy, like technical way, in a very real, important way that literally, if it weren't possible, music would not be possible, if you think about what I'm saying, right? And same thing with, like, if you work in the theater, you can shine a red light on a red spotlight on a spot, and you can shine a blue spotlight on a spot. And one light does not knock the other light out of the way. It's fundamentally lights and sounds and electricity are all very ghostly and seemingly immaterial in the fact that they can actually share space and spread out in space. They're real, but they are not particular. They're real, but they're things like sound and light and heat and electricity. They're very, very real, and they're very part of science, and they're very measurable and predictable in their motions through time and space, but they are somehow not particular or discrete or massive or bounded or countable, et cetera, et cetera. They are the ultimate subject matter of physics 204, but how can they be real? How can something like a water wave or a sound wave actually be real if it's not made up of actual thingy things? The answer is that they are made up of thingy things. This is a long way of saying our first unthingy thing that we're going to study in this class, our first unthingy thing, the motion of which we're going to study in this class, is a wave, specifically say like a water wave or a wave on a stretched spring, a one-dimensional wave, like propagating along a long rope or a long spring, which you'll see in lab 3. That's the first true unthingy thing that we're going to study in this class, is a wave traveling along a long string. But the way such a thing can even exist, the way an immaterial entity can occupy space and time of the material world, is that the truth of the matter is a wave is made up of lots and lots of oscillations, lots and lots of little particles all vibrating, oscillating, moving back and forth in an incredibly intricate, organized pattern of space-time oscillations. So this course starts off with the fundamental ingredient of all unthingy motions, a fundamental ingredient of all propagations, of all wave propagations, of all unthingy motions. One fundamental ingredient is the classical oscillation of a classical thingy thing, i.e. a mass on a spring. So we start all of our analysis with the oscillation of one mass on one spring, so we can get all of the physical principles and practices and the math down for what's happening with one mass on one spring. And then we expand that math to include many, many masses oscillating simultaneously in a very intricate, organized, bizarre way on many, many springs, and that will make a wave. So just so you understand where we're going with this, we're starting with a mass on a spring right now in the 5 minutes we have left, because it's an ingredient, it's a thingy thing ingredient from which we build unthingy motions. In more technical terms, we're starting with the oscillation of a classical particle, so that from the math which describes that, we can build the more modern motion propagation of an immaterial wave. So this is a bridge. This is a transition technically from old material to new material. Okay, I know I have only 5 minutes. So that's why we're doing it. And that's where it's heading. So we have to understand the math, ultimately the differential equation, the calculus that describes one oscillation, so that we can put many oscillations together and build one wave propagation. So I know we only have 5 minutes. We're just getting us rolling here. But here's the deal, right? We have a mass on a spring. And this was the whole setup, right? One edge is fixed to a wall. The spring is described by K. And the very, sorry. And so here's the people that know this 5-step method. Here's my step 1 diagram and fact pattern. There's the diagram. And the fact pattern is that K here is given as 200 newtons per meter. That is, sorry, I'm just looking. Okay. That is a constant that describes the stiffness of the spring measured in newtons per meter, force per unit displacement. Oops, sorry. X naught is the initial place where the initial displacement from equilibrium at which the mass is initially held, and I am watching the time, it's initially held at rest. So wherever it's held at rest away from equilibrium is what we call the initial position X naught. And what else? Oh, and the mass was given as 0.3 kilograms, right? So these were all the givens. This is step 1 diagram fact pattern. Then step 2 of the 5-step method is we were asked, I believe, the actual question 1 was at X equals X naught at the initial displacement of this mass, what is the force exerted by the spring? Stop me if that's wrong. And I know we're just going to get this far and then stop. But I believe the first question was, what's the force exerted by the spring? Right, that's step 2. What's the question? But this is what I'm looking for if you're handing in the homework. So then step 3, general definitions and principles. Step 3, I would say the general definition and principle here, if we're being asked what's the force exerted by the spring, the general definition the general definition or principle that we need here is the force exerted by a spring. It's this, F equals negative KX, which means, in short, I'll say this quick. And now, again, some of you have seen this before. Some of you, what this statement means is that the force exerted by a spring is not a constant strength. It's that it is directly proportional to how far you stretch the spring. If you don't stretch the spring at all, if the edge of the spring, the mass, is sitting at X equals 0 at equilibrium, then the spring is totally relaxed and not exerting anything. But as you start to hold the mass at a farther and farther place from equilibrium, the spring pulls on it, tries to pull it to equilibrium, but pulls it harder and harder. Right? That's what this statement means. It means that the force exerted by the restoring force exerted by a spring is directly proportional to the displacement to which you subject that spring. Not all forces work this way, but this force evidently does. Right? So it's saying that if you made a straight line graph, I mean, if you made a graph of force per displacement, you get a straight line. Okay, so that's step 3, and K is the constant for the spring. So then step 4, particular application and work here. I mean, it is, I know all I'm doing is, I mean, this is just a plugin, but just to get us rolling. So here would be negative 200 newtons per meter times 0.15 meters. And so the meters cancel and you get negative 30 newtons. And this all goes to show that one thing we're just about done. I know it's 1:29. One thing I should have done, my failure, when I drew my original diagram, I really should have made it clear that in this diagram, I'm declaring that anything to the right, I'm calling positive. To anything to the right of the equilibrium, I'm calling positive. Anything to the left, I'm calling negative. I could have made a different choice, but I'll tell you this, but I could have made a different choice. But assuming I'm calling right positive, then the force is pulling negatively. The force must be the opposite direction from displacement. So my final answer for just question number 1, and I know a lot of you got a lot farther than this, but my final answer is the force is negative 30 newtons, meaning it's pulling it to the left 30. That's my step 5 final answer circled. That's the kind of way I'm expecting the homework to be done. Then I think the next answer is 0, if I remember correctly. And then the next answer, I think, is negative 100 or something. Or yeah, I think it's negative 100 for those of you. But that's it. I know class is over. We'll get moving faster and faster as we proceed. But thank you so much. I will stay if there's any questions. I'm here. But thank you. I'll post everything. Thank you. Have a good day.
Thank you, Professor. Have a great day.
Thank you. You too.
Have a good day.
Thank you. You too. Thank you. Awesome. Awesome. Thank you.
Professor, can I ask you something?
Yes, absolutely. Is that David? Yes. Let me turn off the.
So
Yeah.
for